Hi everyone. As we start thermodynamics, there are a few important quantities that I want to introduce in this section. Okay, I've written two important definitions here. To start, thermal energy is the sum of a system's translational, rotational, and vibrational kinetic energies, as well as the potential energies which are stored due to chemical bonds. Then we have heat. Heat is a transfer of energy, so we use heat in everyday language either to mean a verb or a noun, but in physics, heat means a transfer of energy, and specifically, it's a transfer of energy from one substance to another based on a difference in temperature. Both of these quantities are energy, so the SI unit is joules. This variable Q means a transfer of energy itself, though we could say how much energy was transferred and mean Q as well. But we don't use delta Q as we would for kinetic energy and potential energy because Q in itself implies a transfer of energy. In everyday life, we use temperature to indicate how hot or how cold a substance is, and we can think of temperature as a measure of the average microscopic kinetic energy of molecules in a substance. So substances with a higher amount of thermal energy would have a higher temperature than others. And we measure temperature on a scale. So the measurement that we use for temperature itself doesn't measure kinetic energy, but it's a scale that we've used to compare the amount or the average microscopic kinetic energy of different substances. Okay, let's look at our temperature scales. Kelvin is the SI unit for temperature, and it's based on absolute zero. I've mentioned this already, but absolute zero is the point where all molecular motion stops. Celsius, however, is calibrated based on the freezing point of water, 0 degrees, and water's boiling point, which is 100 degrees. In order to convert from Celsius to Kelvin, we'll need to add 273 degrees. Notice, however, there's still 100 Kelvin between water's freezing point and boiling point, and the same in degrees Celsius. This is because 1 degree Kelvin and 1 degree Celsius are the same increment. It's the same amount, essentially, and though it has different starting point. So if we're ever using a change in temperature, which we often are in calorimetry, we can use degrees Celsius or degrees Kelvin because they would be the same value. It's not true, however, for Fahrenheit. I've still included that, but you can see that there's actually 180 degrees Fahrenheit between water freezing and water boiling. So we have 1 degree Celsius equal to 1.8 degrees Fahrenheit, and then also we'd have to recalibrate to the 32 degree freezing point. So we can use Kelvin and degrees Celsius interchangeably as long as it's a temperature change. Otherwise, we can stick with Kelvin, the SI unit. And we know thermometers are devices that measure temperature, and generally thermometers work by measuring how properties of a substance change as temperature changes. And an example of this is a liquid thermometer, usually alcohol or mercury, and that would use the thermal expansion of the liquid with temperature. Or we could have electrical thermometers that measure electrical resistance or resistivity and how that changes with temperature. Radiation thermometers, or also there's some that measure color and how that changes with temperature. Okay, let's move on to use these concepts in calorimetry problems.